In these problems, we're trying to identify the exponent that gives us the power listed right here. So a logarithm is the inverse of an exponent. And remember, the way you read this is to look at it and say, okay, this little sub number, in this case the number is 8, that would be the base. So in this problem, the number 8 is being raised to some power to get the number 64, which I guess is correctly defined as the power. 64 is the power, and we're trying to find the exponent that we raise 8 to get 64. So you see this, and you should think, okay, what power of 8 gives us 64? And the answer is 2, because 8 to the second power is 64. Here, logarithm, right, with the base of 3, we're trying to find the exponent that we raise 3 to get the power of 81, right? So here, 3 times 3 is 9, times 3 is 27, times 3 again is 81. So what is that? Well, times 3 is 9, that's 1, 3, and times 3 again is 27, and times 3 again is 81, right? So that's 3 to the 4th. And all of these problems are right, all about simple situations of evaluating logarithms. So some of the numbers might be larger, but you'll quickly, doing this module a couple of times, I think become familiar with the expectations that you're supposed to be able to handle here. So here, if we have 4 to what power is 64? Well, 4 to the second power is 16, 4 to the third power is 64, right? 4 times 4 times 4, and that's it. So all of these are like that. Here the answer is 2. Why? Because 12 here to the second power is 44. And last one, 15 to what power is 225? What's fun about these kind of situations is that you could know or easily think about 15 squared being 225, but also think about the way that powers work. It can't be 15 to the third power. That would be an enormous number. And you could recognize that anything above 3 would be even larger, so it's got to be squared, right? So you can quickly think about these by estimating, really. In most of these problems, I think in all of them, you're not going to see a fractional answer. Thanks.